All right, so now we're going to be looking at some more advanced problems where we're doing function evaluations. But allow me to give this as a formal, maybe short discussion. But I feel that there's a need to emphasize these kinds of problems right here. Okay, so it is only required to view and learn this lesson after you have learned about on the basic of what a function is, and understand what a function notation is, and be able to operate with giving an input to a function, evaluating a function at a given specific given input. Okay, and now we're going to advance to a more advanced kind of problem for function evaluations. That's all. So I highly believe that this is going to be a short discussion here. Okay, so let me introduce the following function right here. So at this point, as I was saying earlier, I only need anyone viewing this lesson to understand what a function is and know what a function is. So a function at this point is simply a rule that takes an input to an output. Okay, so I am now going to start out by giving a function. So we have a function here, and the rule of this function says how about f of x is x squared plus 3. Okay, so a function at this point in our understanding is simply a rule. This rule says for whatever input x in general, okay, whatever input x generally, we are going to square that input and plus with a value 3, and whatever that computation work comes out, it determines our final output. Yeah. Okay, and then in the way it is here, this function, once we take one input, it is going to give exactly one and only one output for that. So this function here is clearly this rule over here is clearly a function. Okay, and it's not even a formal example yet. I'm just introducing a problem to demonstrate the idea, and then we're going to lead into doing some formal example later on. Okay, and so from this function, you have learned from earlier lessons when I was introducing what a function was. Then this is the function's name, and that x right here is indicating the x variable in our expression here, in our rule here, is the input. And so now anyone viewing this lesson should be well familiar with, how about let's write down some instruction of what to do with this function. How about we want to evaluate, this is easy, f of 2. All right, nothing challenging. So f of 2 here is going to give me, this is the input, okay? We substitute 2 into the input. And so I'm going to have 2 all squared. Now, you can look back throughout my entire lessons and all of my lessons when anytime we were doing function, and specifically anytime I'm giving an input value to a function, it's a habit of mine, but I highly recommend having this habit, because put your input in parentheses because it keeps things clear. So anytime we're substituting an input value into your function, okay, into an expression, keep that value, including its sign, in the parentheses. Okay, so here I have 2 squared plus 3. So nothing looks unusual. We don't need to arrive at this lesson for a problem like this, for something like this. So here it simply says 2 all square, okay, plus 3. So 2 squared is a 4 arithmetically, and then plus 3. So 4 plus 3 is 7. So here's our output. Okay. How about again? Evaluate as a separate problem. F at -5, for example. And this is where I really emphasize again that anytime we're substituting an input value into our input variable here, then use a parentheses. It will guarantee that whatever the operation of our function's rule will affect the sign of that as well. So here, in other words, I'm putting -5 inside parentheses is n squared, and then plus 3 according to the rule. So just like that, the rule says I'm going to square the input. But since the input's being -5, that's why it logically makes sense that we put that -5, the entire value, including the sign, in a pair of parentheses, and then square. So now that square here, with this parentheses, it tells me that the order of operation, it tells me that this square is also effective for the entire negative input. So minus 5 times minus 5, or negative 5 all squared, that's the way how we read it out loud. It's going to be a positive 25 and plus 3. We are now looking at a positive 28. Okay. Nothing unusual. I'm just beating around the bush a little bit. That's about reminding anyone how to evaluate the function at a specific given value. But so at this point so far throughout any work you have done, okay, you might have also learned some lessons about how to graph a function and looking at different graph behaviors of a function prior to this point. You may or you may not, okay? It all depends on how your course is being structured and organized, okay? But understanding the graphical property of a function does not affect our understanding here. But the point is, throughout everything you have learned so far, throughout all problems you have done so far regarding the function evaluation, we've only been doing the kind of problems like this, where we're substituting an actual numerical value into our expression here, into our rule here, to come out with an actual numerical output. All right, but now as a matter of fact, as I have, now I can remind anyone that from the first lesson that I introduced about what a function is, then a function simply is a rule that takes an input to determine an output and determine exactly one and only one output. Okay, but I never said that the input has to be a number. Okay, so now in that way, let's extend and expand our understanding. This is easy. So that discussion stops there. So now I want to evaluate. Same function here is f. But now I'm going to take f of w. How's that? All right, and this is what I meant earlier by saying that the input does not necessarily have to be a numerical value any longer. And that's kind of, this is where things are starting to get a little more advanced, where it starts making some viewers, some students of mine starting to feel uncomfortable. But that's the point. We have to get uncomfortable, and then we will learn and become more mature and be ready to take more challenges waiting ahead for us. Okay, and so keep things on the ground right here. Stay as close as possible on the ground. The only idea is that we're substituting. This is now substituting for x. That's all. This expression here, instead of being a number, this expression as a w is now substituting for our input. You see, this function says whatever the input is given, we square the input and plus 3. Take a moment to digest that understanding, okay, and think through that understanding. So we take this expression as our given input. We substitute that into our current rule over here, and the rule says for any inputs that's given to the function, we are going to square the inputs and plus 3. So in that way, consequently, this is simple. It's going to be, and again, just like that habit that I really emphasized earlier that I highly recommend, put your substitution in a pair of parentheses at start. So w, this is the input substituted for x, all squared. So we have the square because the rule said so. The rule said that we square the inputs. The input now is the entire w. It's not a 1, it's not a 2, it's not a negative 5, it's just some variable, some other variable. Okay? Plus 3. All right, and so now in this situation, we are no longer working with a numerical input. And so in that way, we have no choice other than just simplify. So at this point, all I can say now is that w all squared is simply re-expressed in a more simplified way, a w squared plus 3. But this is our final form right here. So we have this here. This is this is what I call it's an output, but it's also regarded as the final expression. Okay? And of course, simplified. Simplify. All right, so the final expression but being simplified. That's all we can do, okay? Because we don't have numbers. So if we had a value, if we had a number, then it's easy to square and get the perfect square of that number and then plus 3, and we will have a numerical answer. But here we're ending up with a final simplified expression. That's all we can do, and that's the best we can go. All right, and so now that opens a new door for us into doing the next kind of problem, and these kind of problems is where I call that it's the advanced function evaluation. Okay, because we're evaluating a function. This function, this rule, once it's given, we're evaluating that, but at different various expressions given to it. Okay, so let me give it a try again, a different try. And then and then at this point, anyone viewing the lesson here has already had in mind, a picture of where I'm going with this. So what about a 2t minus 1? F at 2t minus 1. That's how I say it. F at 2t minus 1. That's one way of saying it. Or f of 2t minus 1. This next one here, this second one that I just now stated is more formal with the way how I use that proper way of saying in functional notation right here. So f of 2t minus 1. F of 2t minus 1. Again, this is another problem where we no longer have the input to our function as a numerical number, okay, as a numerical value. We're looking at an expression being substituted into our function. So now the entire 2t minus 1 is now going to be substituted into the x. It's going to replace for the x. Okay, and that's why now at this point it is extremely important that you stay with whatever I highly recommended earlier. Put your entire input in a parentheses, in a pair of parentheses, and this is what I mean right here. Good practice. 2t minus 1, that's your input for now. The rule says we square that input, and that's why the whole input, make sure that it stays in parentheses and then square. That is because see, the function says whatever the expression here. I take the whole expression, I square that, and then plus 3. That reflects straight out from our expression in our rule of the function. The function says we square the input. The input now is not one simple number, it's the whole expression, and then it keeps getting more and more complicated and more complicated. But no matter how complicated it can go, we stay with that ground. I've been yelling out loud. Just take the whole expression and substitute that in here, and then use a parentheses anytime that you're doing a substitution. Okay, so I substituted the entire 2t minus 1 into my x. So now x is replaced by this expression 2t minus 1. Okay, and so now at this point right here, now let me also mention a little bit that the reason I highly recommend doing this, because think about what if I skipped parentheses. Very dangerous act. Very dangerous act. Why is it dangerous? If I skipped the parentheses, then the version is going to look as following. If I just put in a 2t minus 1 and then skip the parentheses and just put a square and plus 3. Oh my, this expression sure looks deceiving. Okay, and it will cause a misleading for your next step right here. This will tell you that when anyone will attempt to simplify this expression, the square here according to the order of operations is only effective for that 1 right here. So in other words, we're going to simplify that as 2 minus, see, 1 square is 1, and that square is not even including the negative or the minus sign here, so it's minus 1 again, because 1 square is 1, and then plus 3. So we're going to simplify it down to, so negative 1 plus 3 combining like terms, and we've learned that with that way of saying it's from a previous course right there. So negative 1 combined like term with 3, we're looking at a positive 2, so we simplify with that into a 2t plus 2. But ladies and gentlemen, this is a very incorrect answer. This is a very incorrect answer. Allow me now to show the actual answer here. Okay, so I'm quickly gonna roll over to my other board again. Okay, and I'm gonna show the formal work for this particular problem. All right, so now f of 2t minus 1. Yes, the setup for that originally was 2t minus 1, but in parentheses, r squared plus 3. And so because the setup looked like that, now it tells me that I need to, what I have here as the first term, what I have here is a perfect square of a binomial in here, okay, of a two terms thing, of a two terms expression. So the entire two terms expression here is being squared. All right, so we can start moving slow and start bringing in your understanding from your prerequisite course right here. This squares on the entire binomial here means you can think of that as a 2t minus 1 times a 2t minus 1. It's a product of two identical factors. That's what a square is. And so now you're gonna take your time foiling out and start doing combining like term, and don't forget to add a 3. Okay, and so allow me to assume anyone learning this video lesson is at a pre-calculus level, so you simply just came out from an elementary algebra courses. So all of those skills about foiling a product like this, you should have learned that from your elementary algebra course. Yeah. So you take your time, you can take your time foiling out. Okay, and somewhere here and there in your prerequisite courses, you have picked up fast tricks to speed up your foiling work. Go with that. I am not specifically looking for any particular methods right here. Okay, but allow me to go with the lengthy way right here because it ensures anyone will understand. Okay, so foiling that, I'm looking at, see, 2t times 2t is a 4t squared, and you should be familiar with that operation. 2t times a negative 1 gives me a minus 2t. Minus 1 times 2t gives me another minus 2t. And these are now like terms. That's the language we have picked up from the earlier course. And now negative 1 times negative 1 gives me a positive 1. So all of these are operations we've been so familiar with from a prerequisite course right there. And then don't forget, plus 3. Okay, this is the formal simplification work right here. So now 4t squared is not like term with any of these. So in the next step, I am going to keep 4t squared the same. Okay, so 4t squared, but now these two terms are like terms. Okay, and allow me not to explain what like term means. You should have understood that from your prerequisite course right there. This is now going to be minus 4t as we combine like terms right here. And then these two are like terms right here. We combine them, and then they become plus 4. So ladies and gentlemen, f at 2t minus 1, or f of 2t minus 1, equals the setup. But then as we simplify it down, this is our simplified final expression. Okay, and this is the only one we can have. We cannot expect an actual numerical answer for something like this. Okay, but 4t squared minus 4t plus 4. This is the correct answer right here. All right, so it looks quite different, and I was using parentheses properly here. And so this is the answer it gave, and it looks quite different with the answer that we have had back here that I wrote in red, where if we mistakenly skipped out parentheses, okay, our answer would become something quite wild sometimes, or completely incorrect. Okay, and so now we have a sense about what these kind of advanced function evaluation problems are. All right, it's just about now you have a function given, and it's now time to learn to get comfortable with that. Of course, at first time being exposed to this, it's not comfortable at all for a lot of people. Okay, but then that's the whole point. We learn through it, and we start, getting into things that we're not comfortable with, and then as we keep working on that, and in the end, these are still just the skills that you keep building up. And once you build that, and at one day when you arrive at a higher courses, being fluent at the skills right here, it will be a tremendous usefulness there at your higher level courses. Okay, and so now we are ready for some actual examples. All right, so now let's look at our example 1 right here. All right, so in example 1, I'm going to say we're going to start with having a function defined here. F of x be defined as x squared minus 4x. Okay, x squared minus 4x, and then after having this function defined and given to us right here, then we want to do evaluate. So this is the worded instruction. Okay, evaluate, and of course simplify. Okay, because like how I was demonstrating it through the introduction problems, then once it gets into substituting an expression into a function, then the only thing we can do is to simplify. So evaluate here just simply means we take an expression or we take an input, whatever given input, substitute that into the function. So it's not only to come up with the final answer, but anytime you hear evaluate a function at a given input, that just simply means we take the input and substitute it into the function. And then whatever it is at the end, we're going to simplify, okay, and simplify. So it seems like two things being that we need to do here in the problem, but it's really not that much. Okay, so now part A of the example. Okay, so now I want to do f of x is defined as the rule for f of x. Learn to always remind yourself about the rule once you see the function. The function here has that rule right there, and the rule says we square the inputs and minus 4 times of that input. That's what the rule says. And so now I'm going to apply this rule on W. So here I'm evaluating and eventually simplified f of W. That's what it means. I mean, that's how we say it. But what it means is what I was saying earlier. We're going to apply this rule, that's f. We're going to apply that rule on this specific given input, now being an expression, just simply a variable W. So that means now I'm going to substitute W into everywhere I see my x variable. So use a parentheses anytime that you're doing a substitution. So now with that square, okay, I'm substituting W in that. So the W here replace my x. And then the rule says we're going to minus 4 times. 4 times. So the multiplication right here. 4 times W. So now my substitution reflects exactly the rule of the function. We square the inputs and minus 4 times the inputs. The entire input is being in those pairs of parentheses. All right, and so now we are ready to advance. And this is the reason why I can say we are not able to find the final numerical answer as the outputs, but here we can only simplify this current setup right here to come up with a final simplified expression. Okay, so now what I'm looking at here, first term is going to give me a W squared. That already looked a lot simpler. And then minus 4W. Okay, this is that final simplified expression that I was talking about. And so that's what we just did. We evaluate this function at W, and then we further simplify from here to here. All right, so that first part A of this current example is quite simple. Let's allow these problems to grow more and more challenging. Okay, so now let's look at part B. All right, so what about in part D right here? We are looking at about f of a plus 1. Okay, notice that a plus 1 is the same as 1 plus a, so sometimes I can also have the problem can be written as f of 1 plus a. Watch out for that convention. These are all the same, but there could be times quite often enough later on in your future courses that you will see this expression instead of that. But in the end, they are the 1 plus a or a plus 1. It's the exact same expression. It's just commutative property of addition. Okay, but now let's proceed. Okay, we want to evaluate the function at a plus 1. So we're going to substitute this entire expression a plus 1 into our function. So this is how it started. This is how we are starting it. Okay, so f of a plus 1, that's how I'm saying it, equals, this is the rule of the function. The rule says x squared, the input square, minus 4 times the input. The input square minus 4 times the input. The input now is a plus 1 currently, the input square. This is how I'm writing it. The input square. And that's why for any substitution to provide the input, I put that in parentheses, just like that. Okay, so stay with that ground and you will provide a safe work for yourself and safe steps. Okay, so that anywhere you moving on to the next step, you will always be, you will guarantee at some good percentage of of success. Okay, and then minus 4 times a plus 1. That's how the setup starts. Okay, see, and it's anywhere there's an input, I use parentheses around it. Okay, and minus. Okay, and so now that means I have done a similar work through my demonstration problems earlier. Think of this a plus 1 all square as all right, I can swing over to my other board to do a quick little scratch work with them. All right, so think of this a plus 1 all square. On the scratch work, think of that as a product of two identical factors, a plus 1 and a plus 1. Okay, and then we're going to FOIL. This is, I'm not saying my instruction up here is showing this the fastest method, because you might have picked up a trick here and there that speed up this process a lot faster than how I'm doing it here. That's not the point. Okay, the point is I want to show the methods where it's already familiar to anyone viewing the lesson. Okay, so here it's a times a. Okay, a times a, that gives me a squared. A times 1, that gives me a. 1 times a. 1 times a gives me a again, and 1 times 1, okay, is 1. That's why we call it FOIL. Okay, distributive law of multiplying out. And now let's combine like terms. So these two are like terms. So we're looking at a squared plus 2a plus 1. But now notice, all that here is only the final expression of this perfect square, a plus 1 all square. Okay, now I'm going to bring that into my bring that back to my current problem right here. So all that a plus 1 all square now is regarded as a squared plus 2a plus 1. Okay, and now here it's small steps enough that I'm going to start distributing that 4, but watch out for the sign. It's actually negative 4. So now as I'm distributing that negative 4, it's going to become a minus 4a minus 4. Okay, sign operations. And now I'm going to safely remove the parentheses here, because in front of my parentheses it's just a positive sign, right? So now I'm looking at a squared plus 2a plus 1 minus 4a minus 4. Now we're completely clear from parentheses. You see, I put parentheses here, and then we remove parentheses safely with methods, with understanding, with solid understanding. And then now when we're completely free from parentheses, now let's start really combining like terms. And that's how we're going to arrive at our final expression. And that's the only choice. We can only end up with a final expression, a final simplified expression. These two are like terms. The 1 and the minus 4 are like terms. So now combining those like terms, we're looking at the final simplified expression. A squared, so 2a minus 4a gives me a minus 2a. So a squared minus 2a minus 3. Okay, this is our final expression, like that. Our final simplified expression that equals to the function f evaluated at a plus 1 as the input, like that. All right, so that's how we're doing another example problem. Let's allow these problems to continue growing more challenging and more challenging. Okay, so now let's head into part C of our example. All right, so what about in part C of our example? let's get comfortable with the input that looks like the following. How about f of minus 1 plus h? Minus 1 plus h. Now, anyone viewing this lesson of mine right here, believe me, every problem I put on the board has an intention. So somewhere here and there, right now, my only aim is to have you fluent with that skill, substituting an expression into a given function. Just get comfortable with that. But then at the end of the day, when you get into the next kind of problems, and you're looking back right here, every single little one we do it here, put a little piece of rock into your foundation to build a stronger building for your career later on. Okay, so here it's f of negative 1 plus h. Well, I do notice that negative 1 plus h is also the same as h minus 1. So you can think of that either way. But I prefer stick with this. It may look at the moment a little uncomfortable for us. Okay, we may be a little uncomfortable with looking at it this way instead of that. But like I already advised, be ready to stay with things that you're not so comfortable with, but through that you will learn good things. Okay, so now I admit it's the same as this, but I'm not gonna write it that way. Let's take minus 1 plus h as the input. The rule of the function says we square the inputs and minus 4 times the inputs. So that means in this case right here, we're substituting, we're letting the inputs be minus 1 plus h as an expression. Okay, and so in that way, this is what I'm seeing. The rule says we're going to square the inputs. So first thing to come, the input is negative 1 plus h. Okay, I'm going to square the inputs. That's why parentheses and square. Square the inputs. And then minus 4 times minus 1 plus h. We keep things organized that way. Okay, and now just like that, I'm going to step over to my other board to quickly work out with this little problem. Okay, and so all right, so minus 1 plus h all square is exactly the same as the product is the same, okay, as the product of two identical factors. Minus 1 plus h times minus 1 plus h. And this is where foiling work is needed. Okay. And so now minus 1 times minus 1 is a positive 1. Okay, minus 1 times h is a minus h. H times minus 1 is minus h again. H times h plus h squared. And so now these two are like terms. We're looking at the final expression here being a 1 minus 2h plus h squared. It's a simplified expression right there. Okay, and then notice to anyone who loved to view this, who wanted to view this as h minus 1, you can also see that as h minus 1 times h minus 1, and then your FOIL work will become h squared minus h plus 1, and then it's simplified down to h squared minus 2h plus h. And now you can notice, at first you probably worry a little bit that these two look different, but in the end they are just the same. These are all additive. I mean, these are all commutative due to the property of addition. And so in that way, these two are exactly the same expression. We just rearrange the terms. Okay. All right. So now in that way, back on this board right here, this perfect square is now going to be, in the next step, 1 minus 2h plus h squared. Okay, I'm still keeping that in parentheses. And then this minus 4 distributed into each term right here will switch signs. So now I'm looking at plus 4, okay, minus 4h, plus 4 minus 4h. And then I am going to safely remove the parentheses here, similar to the earlier problem. So now I'm looking at 1 minus 2h plus h squared plus 4 and minus 4h. And now realizing these two h's terms are like terms and these two constant terms are like terms again. So now our final expression is simplified as following. We're looking at these two combined together gives me a 5, okay, and then minus 6h, okay, plus h squared. Okay, that's one way of seeing it. Or you can write this as, this is exactly the same as h squared minus 6h plus 5. Okay, that is completely legal doing that. All right, so that's one more problem where we evaluated our function, our given function here at this expression, this given expression being minus 1 plus h. Okay, let's try another one. All right, so how about in part D right here? Let's look at how about f of 2x minus 1. Okay, it has been h and w for some other variables name, and here I'm using x again, so somebody may worry that is that the same x with this. That's not even a problem to worry about. Okay, it's just, once again, the only basic we keep here, the only ground that we keep here is that we take whatever input that is and substitute that into our rule right here. The rule says the input, square of the input, minus 4 times the input. That's what matters for us right now. We just, whatever that rule will be applied on this input expression right there. Okay, so now I'm looking at the rule says the input, currently 2x minus 1 being squared. Okay, in parentheses again. All right, because that's how it will indicate that this square is for the entire inputs, not just for the 1, not just for the 2x. Minus 4 times 2x minus 1. Okay, and so in that way, now I'm looking at, so you can pause the video and go ahead and find your own foiling work for this. I've done this often enough, so you can also work with this independently. Okay, but then, and then compare with my answer down here. So after foiling, okay, like I said, you can always pause the video, do your own work or your own steps, like the work I've been doing on the other board right there for scratch work. Okay, but now if you're doing this foiling work properly, then you should be ending up with a 4x squared minus 4x plus 1. That's what will come out after foiling this perfect square right there. Okay, and then we're gonna subtract 4 times the input, just like that. And so now, just like how we've been doing the earlier problem, the earlier problems. So minus 4 distributed for each term here will switch sign. Okay, and so that now gives me minus 8x plus 4. Okay, and then these two, I mean this pair of parentheses is, since we have just simply a positive sign in front, then this pair of parentheses can be removed safely and completely legally. So in that way, I'm looking at a 4x squared minus 4x plus 1. Okay, and now we have some like terms to combine right here. So minus 4x with minus 8x. Okay, now I'm looking at 4x squared minus these two together combined, it's minus 12x. And then the 1 and the 4 combined together, plus 5. That is, ladies and gentlemen, this is our final simplified expression for f of 2x minus 1. All right, so now we have done many problems enough to the point at which all we need is to get ourselves comfortable with that skill, to take whatever expression given as the input, okay, and put that in, plug that into our functions, and apply the rule of our function on that specific the given input. Okay, all right. So let's keep trying. So as I was saying earlier, this video is aimed to build a foundation for anyone. So let's try as many problems as we can. Okay. So now let's look at part E of the example. So how about f of square root of x? F of square root of x. Okay, the input this time is the expression square root of x. Let's not be too worried about what kind of expression it looks like, but the first thing we stay with, the input now is given as square root of x. Square root of x. That's the input. The rule says we're going to square the input. Square the input. See? Again, I'm putting parentheses around my input expression, the entire thing. Okay? And then the rule says I'm going to subtract 4 times the input. That's how I substitute it in my input expression. Okay, and so now, according to the way how the operation is, square, the square will cancel with the square root, and you should have learned that. I don't think I need to go too far into that detail, but you should have learned that. So square will cancel with the square root. Now it gives me an x. So square root in being squared, it's just simply now x minus, and then now we have nothing else to be done here other than just minus 4 square root of x. Okay, this is our simplified final expression already for this particular function, f of square root of x, for this evaluation of the function. Okay, all right, how about one more try? And so at this point, you can sense that it is extremely vital that you have mastered all of your skills that you have built from your prerequisite courses, including like foiling, okay, being able to foiling, understand what a square is and how square will cancel out with square root and all that. Okay, there's a couple more skills that need to be reminded here. Okay, so how about problem F of this current example? Okay. So what about f at x cubed, okay, or f of x cubed? What's the input here? The input is x cubed. The input here is x cubed as an expression. So it's x cubed being substituted for this expression. So once again, the rule of the function says with the inputs currently being cubed, the rule says we're going to square the inputs. That's why, and again, parentheses is. Okay, so x cubed all squared minus 4 times x cubed. See, so anywhere I substituted my input into the rule, I'm just simply putting a pair of parentheses around it. Okay, and so now another reminder from your prerequisite course right here. The square, a power of a power. A power of a power means, or a power being raised to another power. The final product here is going to give me x to the, we're going to multiply these two powers together. Okay, so somewhere here and there we're going to keep picking back our understanding that we've learned from previous course. So here that property you need to be reminded from your previous course. A power being raised to another power, or it's a power of another power. So now it's a power 6. We multiply the two powers together. Okay, and now minus. This is easy. That's nothing but just minus 4x cubed. That's your final simplified expression. All right, and so now we're good. I believe at this point we are pretty comfortable. Okay, anyone viewing, and of course it is impossible for me to cover all kinds of evaluation problems out there, but I hope we have done this here repeatedly enough to the point that you start clicking with some routine right there. Okay, and that ground I've been yelling out loud, just stay with, take your inputs, bring the whole thing into your rule right there. Okay, and so it could be different rules for different function that you're working with. Okay, but in the end, see, once you have substituted in your input right there, make sure when you are substituting in your input, make sure you put parentheses around your inputs. It's a recommendation from me that's highly recommended, so that you keep your work organized and safe and safely moved on. Okay, all right. So now we're done with example 1. Let's look at another example. More practice for us, but it also introduces another class of problems. All right, so let's now look at example 2. Okay, so we're going to have, how about g of x? I name my function g. Whatever rule I'm about to see here, I name that. It's g. Okay, it takes the inputs x. So the rule says take square root of x and plus 1. Now, so notice, according to the order of operation and in the way how it's written right here, we only take square root of the inputs. And then after whatever that is, we plus 1. Order of operations. Okay, anyone learning from this lesson needs to master already your order of operations. Okay, so g of x equals square root of x plus 1, or the function, the rule of the rule says we take square root of any input and we add 1. Okay, so now from that function, again we're going to do similar thing. We want to evaluate, okay, and simplify. So it looks nothing unusual compared to the earlier example, other than I switched to a different function, a different rule. Okay, but now let's look at part A right here. So I'm still beating around the bush. G of x minus 1. Okay, nothing unusual. The input is here as an expression, x minus 1. That's this being underlined by our squiggling line right there. That's the input. So I'm going to, after recognizing that input, I'm going to substitute the entire input into the function here. And the rule of the function says for whatever input that is, we're going to take the square root and plus 1. That's what the rule of this function g said. Okay, and now being inside of the root here, and nothing inside the root that comes before the parentheses is here. So we can simplify that as square root of x minus 1 and plus 1. Just a silly reminder, but please do not cancel that negative 1 with this plus 1. They are not like term. This minus 1 term is inside the root. It's a completely different world. So in other words, this expression is already final and simplified. Okay, so one nice little problem that reminds anyone about the operation of the square root right here. And then let's now advance to the next problem where we are, so part B of the example, where we are going to keep facing further challenging problems regarding this particular function. All right, so part B of the example. Let's look at, so the same function here, g of x equals or defined as square root of x plus 1. Let's look at g of x squared. All right, so g of x squared. So here I have x squared as an expression being inside, being the input variable. Okay, so again I repeat, x squared here as one expression, as an entire expression being used as the input for our function here. So in this notation, the way it reads, again, it's g is the rule, but the rule applies. See, the parentheses notation here is indicating that this whole x squared is substituting for the input. Okay, so in that way, now the starting setup is going to be the following. The rule of the function, again, the rule of this function g says for whatever input that is. So x squared is the entire input. So I'm going to put x squared in the parentheses. Okay, and the rule says we're going to take the square root of the input, and then we're going to add 1. And so I set that with the order of operations. So the rule here says we take square root of the expression of the inputs first, and then we're going to add 1 after. Okay, and so in that way, now let me produce another step right here. So that means that here inside of the square root here, I can safely remove or take away the parentheses to leave square root of x squared plus 1. Square root of x squared plus 1. Okay, so, and that was simply because the sign in front of the parentheses here was, but it's still inside the square root, was still a positive sign. Okay, but now in order, this expression right here is unfortunately not the the simplest form yet. It's not in a simplified form yet. It's not final yet. So now this is the part where I really have to yell it out loud here. For anyone who would like to study formally and would like to have some serious learning in math. Now, square root of x squared is not simply going to become x. Okay? Square root of x squared. Now notice the way how it is the square is inside of the square root. This is not going to be equals to simply just x. Okay? That is only about halfway of the understanding. Okay? It is true, but it's not entirely equal to x. So the real truthful answer for this, and this is something that, because I assume anyone viewing this video is in a pre-calculus level, and then you are on your way to merge out to any further advanced math. And so when you're at this level, allow me to show the serious and the formal understanding of this. Square root of an x squared is indeed and truthfully absolute value of x plus 1. Okay? Your professor at the prerequisite course should have mentioned the reason why this happened. But for in this particular lesson right here, I am not going to mention the reason why, but in some other, you can find my other lessons, my other video lectures right there where I explain this, the kind of video where I designated for the prerequisite course. But for as a generality out there, anytime so, the capital X here is to represent any expression. So anytime out there when you're taking the square root of a perfect square expression, the square root of a perfect square expression. So mainly what should have caught your attention here is the square is inside the perfect square expression is inside the root. And that after taking square, we should always end up with absolute value of x. Okay? And so this is one generality that it should have been introduced, but sadly it's faded away quickly. Okay, it's faded away quickly in a lot of students right here. So here I would like to remind you that. Okay, and so now this is where we call that the actual final simplified expression of our part B of the example. All right, and so that is how we have done part B right there. And specifically, I would like to remind anyone about this property and a little more about that. But it's actually, when you have a square root of an expression and then the square is outside, this is simply just the expression without the absolute value, but then here is a different case right there. Okay, and then you can look for resources over the web as well to explain why this is the case, but this is actually the case right there. Okay. All right, so now I'm gonna clear out part B and the work we have done. Let's now look at part C of the example. All right, so in part C, let's spend some time writing it down right here. So I would like to look at, how about g of, so 1 plus h, okay, minus g of 1. All right, and so, and just a quick little note right here, but this g of 1 plus h here, just a little note right here, is the same as g of h plus 1. Okay, so if you wrote it this way, it would be the same, because essentially the part that the expression in between the parentheses here are just, those two are just exactly the same. They are just the different forms is because addition is commutative. Okay, so that's something for you to be aware. All right, but now mainly as a problem in part C right here, this is the setup we would like to get to. All right, so you can see that problems keep getting more challenging and more challenging. But now let's have a look at this. So here's g of 1 plus h. So now again, just like that kind of work we've been doing, g is our rule. G is the name of this rule. The rule says, and whatever in between the parentheses, that's the input. So now generally for any input that we call x, then the rule says, the rule of this function says, we need to take the square root of the input, and then after that we're going to add 1. Okay, so now in this particular expression, we're looking at the entire expression 1 plus h is going to be substituted for the input. Okay, and then here we're going to subtract we're going to subtract the function of the function at x equals 1, at the input equals 1. Okay, and so now I'm going to use some scratch work again. So I'm going to navigate over to my other board and complete out this part right here. Okay. All right, so on this board space of mine that I'm going to be using as a scratch work, then g of 1 plus h, the rule says we take the square root of the input. The entire, again I remind you, the entire 1 plus h here is the expression that's substituted for the input, that is used as the input. So now from where the input is, from whatever the input is, 1 plus h, that is why once again using parentheses is extremely important. Okay, it keeps your work organized and it indicates clearly where or which part, which expression, one single quantity or one entire expression is your input. Okay, so we take the square root of that input, and then after doing that, we're going to add 1. After doing that, we're going to add 1. All right, so g of 1 plus h is the square root of this input, and plus 1. And then that is the reason why now we can just, now inside the square root, we can just simply take away the parentheses here. And the sign that is still inside the square root, but in front of the parentheses here is positive sign. So now we can just simply take away without worrying about sign change. And so this is my final simplified expression of this g of 1 plus h. Okay, and so now I am going to bring this into my other board, and this is supposedly the next step. Okay, that the next step, the final work for my g of 1 plus h. All right, so g of 1 plus h is right here. All right, so now I'm looking at g of 1 plus h is the same as, okay, the square root of 1 plus h plus 1. This is g of 1 plus h. All right, and now I'm going to put that in parentheses for now, because this is a group indicating whatever being grouped inside parentheses here is the end result just for that particular term. So the g of 1 plus h is one term. Okay, in another way of saying. And then now I'm going to subtract because the expression is indicating so. Okay, and then now g of 1. So I'm going to produce another pair of brackets right here to indicate that there comes another group. So this group here is simply the evaluation for g of 1. So g of 1, again, the rule is g. And the rule says we take square root of the input. The input here in this case is specifically a given value. So now it's square root of the input 1. See, so anytime I'm giving an input, either a specific value or an expression, I first started out using parentheses to indicate it that whatever inside parentheses is, that's my input. And then plus 1 after. Okay, so in the next step, we can see that we can we can take away the parentheses here. Okay, because in front of that group, it's just a positive sign. So now square root of 1 plus h, okay, plus 1. And then now here square root of 1 is simply just 1, but now I'm not gonna rush the step. I'm gonna take away the brackets here so that minus the square root of 1. Okay, and then minus, this minus sign will change the sign of that 1 as well. So minus 1. All right, and now we're gonna cancel. These are like terms like that and opposite terms, so they can get canceled. So in the end, and here square root of 1, needless to say, this is 1 overall. Okay, and so in the end, my final answer for this case here, for this particular problem, is going to be, it's a square root of 1 plus h. Okay, that's what's remained here, because there are no like terms, there are no other terms that being like it. Okay, and then minus 1. So ladies and gentlemen, this is our final simplified expression, okay, for this particular setup right there, for this particular problem. Okay, the problem is asking us to, evaluate and then simplify this instructed setup like that. Okay, that instructed expression. So it's everything here, every step is an expression. It's an expression here, and then we come to the next expression that reflects whatever being indicated here, being expressed here. And then we keep reducing down and reducing down or simplifying down the expressions. All right, so now let's and so here, this problem here, the main aim, we can start realizing that, you know, it's not only about we are being able to substitute an expression into a function, but we can further substitute with multiple inputs and then do a subtraction and do an adding and even do multiplications between the two different functions at different inputs like that. Okay, let's now look at part D of the example. So I'm going to retain some information. All right, so here we go. This is now part D of the example. Let's look at the question D now is asking, find, evaluate, and simplify g of 1 plus h, and then minus g of 1 minus h. G of 1 minus h. Okay, so the work here is very similar to the earlier problem in part C right there. So, but instead of g of 1 here, now we're looking at g of 1 minus h, so another expression. So one same rule g, but being evaluated at two separate different expressions for as inputs. Okay, and then once we nail down what that is, and once we would nail down what this is, we're gonna proceed into subtracting the two. Okay, so I'm also trying to point out the order of the work here. So we need to nail down what final expression that is, and we need to about the same time nail down what final expression this would give, and then once we've had both of those, we're gonna subtract the two. Okay, and so now I'm gonna get an equal sign ready here, and I'm gonna use my scratch work on the other board right there I'm gonna use a space on the other board for another scratch work again. So again, this is just the formal, the beginning expression instructing us what to do. So now on my other board, I already had the work for g of 1 plus h, and the entire example 2 here is all under that function g. It's all drawing out from that function g of x, which is the rule was given on the other board. Okay, so the work we've had here for g of 1 plus h can still be reused here. Okay, so now I'm gonna just simply throw in this scratch work here, I'm gonna just throw in one more little work. So use as much scratch work as possible. So always, it's math, it's us, we're the math people, we're the people doing math. Have a lot of scratch papers for yourself. Okay, so g of 1 minus h, this is the inputs. Okay, everything in. So when you read this function notation right there, it's indicating that now we're substituting the entire 1 minus h for the inputs, for the general inputs. So in that way, now the rule, so once you have recognized clearly your inputs, then you're gonna say it out loud for whatever input that is. The rule says we take the square root of the input. And so now it appears to be square root of 1 minus h. See? So once you recognize the inputs, writing that down is just the consequence because the rule said so. The rule apply on that input. And then after taking square root of the input, the rule further said we're going to add 1. All right. And so now at this point, we are going to look to see if we can take away the parentheses. And yes, we can. Now, outside of the parentheses, but still in the square root here, it was a positive sign. Okay, so now I can safely take away the parentheses without worrying about sign change. Okay, and plus 1. Now, I do need to mention this in case it confuses, in case it's confusing for anyone, but I've had students when classes are face to face, I've had students who mistakenly write this, who mistakenly think that 1 minus h is the same as h minus 1. I have to say it out loud here. It's not the same as h minus 1. Addition is commutative. You can switch around. H plus 1 or 1 plus h is the same, but subtraction is not. Okay, it's the entire opposite expression right there. Okay, and so just be aware about that. So anytime we are looking at a subtraction, an expression that involves subtraction, keep it in the order how it appears from the beginning. Okay, But now that is my final, at least this is our final simplified expression for g of 1 minus h, or g at that input 1 minus h. Okay, and so now I'm going to take this, and I'm also going to take that work that we have done previously into the other board and fill that into the formal work right there. Alright, so now in that way, g of 1 plus h, from the scratch work that we were working with, we're looking at the square root of 1 plus h plus 1. So allow me to use parentheses here to indicate that this entire group, to group out and isolate out and indicate that this entire expression here is only the consequence, the ending result of this g of 1 plus h, only for that first term, the developed part out of that. But then the instruction from this expression says we need to continue further by subtracting g of 1 minus h. And so I'm going to now open another pair of parentheses. Now this g of 1 minus h, our work from over there, now the next work from the scratch work we have seen earlier is now going to be copy and paste in here. Okay, so here I'm looking at square root of 1 minus h plus 1 again. Okay, so again I can just quickly swing by the other board and to indicate that right here. Okay, everything here is a replacement. That whole group right here is replacing this g of 1 minus h. Okay, or substituting for g of 1 minus h. Okay, and so now we are ready to take away parentheses and combine like terms to finally simplify our final expression. All right, so in front of this group, in front of this pair of parentheses, the sign is just simply a positive sign. So now we can just simply take away the parentheses without worrying about sign changes. Okay, but now be careful with that negative sign right here. With this subtraction sign, it's a subtraction sign, but it's also a negative. So now when we take away the parentheses, we are going to switch the signs in every term inside of this group. So now that means I'm going to have a minus square root of 1 minus h, okay, and minus 1. All right, and minus 1. And so now it's time to start combining like terms. These two are like terms, and further they are opposite terms. We can cancel them. Okay, but these two, they're not like terms and neither opposite terms. I should have said they're not opposite terms and neither like terms. And so we can't cancel these, and we have to leave these the way they are. So now at the final step right here, where things are quite simplified at this point, we have what we have left behind here is a square root of 1 plus h minus the square root of 1 minus h. Okay, and this is now our, ladies and gentlemen, our final simplified expression for this particular expression from the starting point right there. All right, and so that's how we have this particular problem done right there. Okay, so that is everything I would like to mention in this kind of problem right here, because the way how we evaluate an input, the way how we provide an input to a function, and the way how we evaluate a function at a specific input keeps getting more advanced and more advanced. Okay, and so it is not possible for me to cover every kind of problems out there, but I hope you take the idea from here and start exploring on your own. And when it comes to these work right here, yes, I highly recommend to be patient. Okay, be patient and get your work laid down and use as much scratch work as possible to learn to use the papers and pencil and spend your time. Okay, and it may take long today, but it will get better tomorrow, and then it will keep getting better the day after tomorrow. All right.